All right, so with the kite, the one thing that we need to remember is that with the line of symmetry being here, that there's only one pair of angles that are equal in measurement, and then the other pair are not equal. So the four angles of a kite added up to 360 degrees. So I take 360 degrees, take away the two angles that I have, which add up to 90 degrees. So that means the two remaining angles will add up to 270. And then if I take the 270 and divide it by 2, since those two angles that are marked green are the same, that means each angle, which I'll call both of them x's, each angle x is 135 degrees. In problem 10, we have two sets of sides that are equal. So this y plus 7 is also how this side to the right will be marked, since they're both the same. And the side down here, at the bottom left, it will be marked 2y plus 1, because the two sides here at the bottom are marked the same. So altogether, if I'm looking at perimeter, if I go around the shape and add up the y's, I have two y's, a y, and another two y's. That's 6 y's altogether. And 1 plus 7 is 8, and 1 plus 7 is also another 8. So 8 and 8 is 16. So if I add up those four sides, I get 6y plus 16. And those four sides add up to 94. So if I subtract away the 16 from both sides, that's going to leave me with 78. And then if I divide by 6, y has a value of 13. Anytime I use both diagonals, the key here is, remember, we have four right triangles, and the top two are the same. We talked about that based on using like hypotenuse leg, or since these two sides here are the same measurement, which I'm going to mark next, we can say they're congruent by side. So these two are here the same, so that makes y automatically 15. And the angle here, x, is 90, because when the two diagonals of a rhombus, kite, and square are perpendicular. So the second problem, this one here is, again, those are the right angles. That 53-degree angle is over here. And the reason why I'm marking the 53 again is I want to make sure I have as many of the measurements as possible. Like this length 3 goes over here, and that length x goes here, and y goes over here. Again, we may not use all these letters, but the idea here is to try to get a big picture of what's happening. So marking everything that we know to be congruent fills in a lot of the pieces for us. So the angle y down here, we have a 90 and a 53, and we have to look for the third angle for this triangle. So if I take 180 degrees, take away the 90, and then take away the 53, to see what's left is 37 degrees. So both of these angles down at the bottom are 37 degrees. For x, this one here, hopefully you saw how to do this one, but this is one of those I found in years past. Students are not really sure what to do with it. We have a right triangle, and we have two sides of a right triangle. So to find the third side, we would use Pythagorean theorem. So 4 squared plus 3 squared equals x squared. and we solve for x. So x squared is equal to 4 squared plus 3 squared, which is 25. So x would be 5. All right, so for the last set of problems, we're now looking at a rhombus. We have a rectangle will show up, and the last two problems are squares. So if you go ahead and why don't you do the rhombuses first? There's 3 of those, and then turn the video back on when you're ready to continue. All right, so for a rhombus, again, anytime I see the diagonals of a rhombus rhombus, a square, and a kite, I generally mark the right angles. So this length here is a 4, and based on the picture above, this length is also 4. So y is 4, and this length here, DE and EB are the same. So this is 3. And we're looking for x, which is right here. And this is real similar to the previous problem in that we have a right triangle here. And this length is 3, and this length here, y, is 4. So we're going to be using the Pythagorean theorem. It's actually the same problem as this one here. We have a 3 and a 4, and we're looking for the hypotenuse. And here we're looking for a 3 and a 4, and we're looking for the hypotenuse. So the hypotenuse is square root of 25, or 5. For this problem here, in terms of angles, these 4 angles here are the same. And these 4 angles here are the same. Based on the work we've done so far. So that means that angle x here is going to be 21 degrees. Because we have a right triangle, and we have a 21 degree angle and a right angle, and we're looking for the third angle, we just take 180, take away the 90 that we have at E, and the 21 degree angle here we have here at D, and we see what's left of the 180, and that will tell me what y is. So y would be 69 degrees. And for the last rhombus, this is all about perimeter, and so we're not doing any work with the angles, so I'm not going to mark the angles at E. Again, if I see angles I'm working with inside here, I generally mark this as these angles at E as a right angles, because quite often I might be using the Pythagorean theorem, especially if I'm looking for a missing side. But in this case here, no angle measurements are given. So all we're told is that the perimeter is 68. So all 4 sides are equal. So the equation would be 4x, add the 4 x's, equals 68. And if you divide both sides by 4, we get a final answer for x to be 17. And for the next set of problems, we have 3 rectangles and 2 squares. So if you would go ahead and complete those, and we'll take a look at the final 5 problems for this activity. So to save a little bit of time, I went ahead and marked some of the rectangle pictures so that information is already there. So based on our toolkit, the opposite sides of a rectangle are equal. So I marked this side as y minus 3 because this one is. and the bottom marked y plus 12 because, again, opposite sides equal. The perimeter is 126. So I'm going to set up an equation equal to 126. So as I go around the shape, I have y, 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 and y, so that's 4 y's. And negative 3 plus 12 is 9, and 12 minus 3 is 9, so 9 makes 18. So it's 4y plus 18 equals 126. Subtract 18 from both sides, and you get 108. And if I divide both sides by 4, what I end up with 108 divided by 4 is 27. So y is 27. This one here, we're given a 10, and if you look at the picture, actually all 4 of these pieces are 10s. So x is 10. And then we're looking for the length of y here. And we have a rectangle, and we're told this length here is 12. And this problem may look like it's not possible to do. But again, rectangle has a right angle right here. So the height of this right triangle is 12. We're looking for the length of it, which is y. And the hypotenuse is this length here, which is made up of the x and the 10. But again, the 10 is actually the length of all 4 of these pieces. So if I make this a 10 as well, 10, 10 makes total length 20. So because we have a right triangle, we can solve this problem using the Pythagorean theorem. I'll leave that one for you to complete if you didn't see it as a Pythagorean theorem problem. For the rectangle, we have a rotation. So these 2 angles are equal, and these 2 angles are equal. And it is a rectangle, so that means the opposite angles are not only are they equal, but they're also 90s. So that would make this angle here 16 degrees, since the 3 angles have to add up to 180. And since these 2 angles are the same, then that makes this angle here 16 degrees as well. Right. For the last problem, the square, this one here actually is a Pythagorean theorem problem. So we have a right triangle here, so we have x squared plus x squared equals 12 squared, which is the hypotenuse. So 2x squares, add x squared plus x squared is 2x squares, is going to equal 144. And if I divide by 2, that means x squared is 72. And then x would be equal to the square root of that. So x is the square root of 72. All right, so for the last problem, we have 15. So if I start marking things, these 4 things are equal. And for the angle at the center where the diagonals intersect, those are all 90s. And the one thing we talked about with the squared, and again it should be in your toolkit, is that all of these angles here, when we put in both diagonals, are all 45s. So z is going to be 15, since all 4 of these pieces are the same. Y is 90, because all the angles at the intersection of the diagonals are all 90s. And because all the angles going all the way around these are all 45s, x is 45 degrees. So if you did well on this, again, this is your first attempt out of, I think there's 4 activities I have all together, and you're going to be working on the second one here in a moment. So continue with the next.